Hello viewers, welcome to the lecture series of numbers and system. So we have already studied about numbers, real numbers, natural numbers, and we have seen couple of divisibility tests, counting zeros and how to identify the unit digit. And now we are going to move ahead with our lecture number 2, in which we are going to see couple of examples, few problems. So this session is going to be completely based on problem solving. So let's get started with our first problem. So the first problem is, if n is a natural number, then n to the power 1 by 2 is. So here it asks, so if we are provided with a natural number and if we take square root of that number, so is it always a natural number? Is it a rational number? Is it an irrational number? Or either natural number or an irrational number? So let us see. So to approach this question, what we are going to do? We are going to look for examples such that this condition is satisfied, or we can also try to find out those examples such that this condition is not satisfied. So if I choose n equal to 4, in that case, 4 to the power 1 by 2 is going to be 2. So it is a natural number as well as a rational number. And if I choose n equal to 3, in that case, n to the power 3 to the power 1 by 2, it is not a natural number, and it is not a rational number, and it is a irrational number. So in that case, which option is correct? Always a natural number? No. Always a rational number? No. Always a irrational number? No. So which is the correct answer? So D should be the correct answer. So moving on to problem number 2. What is the value of x for which x, x plus 1 and x plus 3 are all prime number? From the option we can check. So we have first of all x equal to 0. So 0 is obviously not a prime number. So we have to just, we can neglect this option. We can discard this option by just looking at it. Next we have 2. So let's see if 2 works or not. 2. X plus 1 will be 3. X plus 3 will be 5. And 2, 3, 5. All of these are prime numbers. So option number B is correct. Problem number 3. The sum of 3 prime numbers is 100. If one of them exceeds another by 36, then one of the number is. So we are provided that we have 3 prime numbers. Let us suppose x, y, and z, and their sum is given that is 100. And x, y, z are primes. And one more thing is given to us is one of them exceeds another by 36. Then one number is, we have to find out what is one of the number. So we have the sum is 3, the sum of 3 primes is 100. So one thing here is to note, interesting thing to note is, when we add 2 odd numbers, the sum is always a even number. And when we add 3 odd numbers, then the sum is an odd number. And since the sum of these 3 given prime numbers is 100, which is a even number, that means one of the number out of 3 should be a even number. And now try to recall from lecture number 1, the only even prime number we have is 2. So one of the number should be 2. Now out of 3 number, one of them is 2. Now we know that 2 is one of the prime number that we are looking for, and now we are interested in looking for other 2 numbers. So let's see. So therefore the sum of remaining 2 prime numbers should be 100 minus 2 equal to 98. And now suppose one of the number is x, then the other number is x plus 36. So x plus x equal to 36 equal to 98. That is given to us. So when we add x and x, we have 2x equal to 62. And on simplification, we get x equal to 31, which is a prime number. So therefore, the answer is none of these, because 31 is not present in any of these options. Okay. So moving on to problem number 4. Here it says x, y, z are prime numbers and x plus y plus z is 38. So the sum of these three prime numbers is given to us equal to 38. And we are asked what is the maximum value of x. So again, like previous problem, the sum of these three prime numbers is a even number. And we know that if we add three odd numbers, the sum is going to be an odd number. Okay. So now it means one out of these three prime numbers should definitely be an even number. Okay. And only even number which is a prime is 2. So therefore, out of x, y, and z, let us suppose z is that number 2. So now what we have, x plus y equal to 36. So for maximum value of x, we put the minimum value of y. Obviously, if we want the maximum value of x, then we have to make sure that the y takes the minimum value. Then only x will be able to take the maximum, because the sum is fixed. We have to make sure that the sum of x and y is 36. And to make that possible and to make sure that x is maximum, y should be minimum. So hence after 2, the next minimum prime number is 3. But for 3, y equal to 3, z equal to 2, we get x equal to 33, which is not a prime number. So we need to find another number that we can choose for y, and we get a number which is a prime. So y, if we choose y equal to 5, then and z equal to 2, we get x equal to 31. So is it a prime number? Yes. X equal to 31 is a prime number. So hence the maximum value of x is 31. So the option number C here is correct. Let us move further to problem number 5. So in problem number 5, it asks how many pairs of natural number are there such that the difference of squares is 35. Let us try to read this question once again. How many pairs of natural numbers are there? We have to identify how many pairs. Pairs means duo of those two natural numbers. We have to identify two natural numbers. We have to identify how many natural numbers have property that difference of their squares. Suppose I take x and another is y. And if I take this x square and y square, their difference should be 35. That's what we are asking here. Let's see how do we do it. Suppose we have natural numbers a and b, and I want their square difference of their squares. A square minus b square should be equal to 35. And you know, a square minus b square is equal to a plus b times a minus b. Okay, so that turns out to be 35. So we have what possibilities we have for this case? 1 into 35 and 5 into 7. So that is 2 pairs are possible. Hence, which option is correct? Option number B. So in the next problem, problem number 6, if A and B are odd numbers, then which of the following is even? We are provided with 2 odd numbers, A and B. Then which of the following conditions, some relation with A and B is provided to us, and we have to identify which of them is going to turn out as a even number. So let us see. So first of all, we have A and B as odds, and we have already seen this thing in previous examples that when 2 odd numbers are added, the resultant number is always a even number. And if the product of 2 odd number is taken, the resultant number is a odd number. Now, let's see option number A. So for option number A, we have A plus B plus 2AB. So A is an odd number, B is an odd number. So their sum is going to be a even number. Now, A is an odd number, B is an odd number, and as discussed, their product is going to be a odd number. Now, what do we have here? We have an even number plus 2 times of a odd number. And whenever we multiply any number, whether it is an even or an odd number, the resultant is a even number. So we have an even number plus an even number. Therefore, the final result is going to be a even number. Next, let us check option number B. So A plus B minus 1. So A is an odd number, B is an odd number, and their sum is a even number. And when we take the difference of minus 1, so definitely after an even number, there is an odd number. Before an even number, there is an odd number. So even minus 1 is going to be a odd number. Option number C. A is an odd number, B is an odd number, their sum is going to be even. And as I just mentioned now, that before an even number and after an even number, there is an odd number. So this sum is going to be a odd number. A plus B plus 2AB. So this is the same option as we had in option number A. So this is going to be even. So A and D. We have A and D as our correct answers. So let us move ahead and look at the next problem, that is problem number 7. Let A and B, A is not equal to B, is 2-digit prime number such that BA is also a prime number. The sum of all such number is. So it is given to us that AB is a prime number, and it is also given to us that A is not equal to B. So what are the possibilities for two-digit prime number? So they are definitely going to lie from 10 to 99. Okay, so number greater than 10 and less than 99, all are two-digit prime numbers. So let us check what are all those numbers which satisfy this property, such that if AB is a prime number, then BA is also going to be a prime number. So 13 is one of the possibility, correct? 13 and 31, both are prime numbers, AB and BA, correct? So this works here. So next, let us see what other number do we have here. 17 and 71. Yes, it's a prime number. 3773. Yes, it's a prime number. 79 is a prime number. 97, it is also a prime number. So next, what we are asked, we have successfully identified all those cases which are prime, and or to be more precise, AB is a prime and BA is also a prime. Those numbers which satisfy this property, we have successfully identified such numbers here. So these are the list. This is the list of all those numbers. So next, what we have asked? We have asked to find out sum of all such numbers. So just what do you have? What do you have to do? Just take these numbers and take the sum, and it will be 418 for you. So which option is correct? 418. Option number B. Problem number 8. The sum of natural number and its square equals a product of first 3 prime numbers. The number is. So what do we have here? We have 3 natural numbers, and it says the sum of these natural number and its square equal the product of first 3 prime numbers. I hope you guys know what are first 3 prime numbers. If you don't know what are first 3 prime numbers, then this question is impossible for you. So let's look at the solution. So let us suppose let the number be x, and according to question, we are given that x plus x square is equal to the product of first 3 prime numbers. What are first 3 prime numbers? 2, 3 and 5. So taking their product, we have 30. So it is given to us that x plus x square is equal to 30. So rearranging the terms, we have x square plus x minus 30, that is equal to 0. Now, what we have to do here? We have to do the middle term split. So how do we do that? First of all, identify that it is given 1 here. So 1 times 30 minus 30 is minus 30. So now try to identify what are all those cases which when multiplied gives you minus 30 and their sum is 1 plus 1. So only possibility for that is 6 times of minus 5. Okay. Minus 5 times of 6 also works, but this works better because we want the sum to be plus 1, not okay. So that works better here, because if we take minus 5x plus 6x, in that case also we get plus 1 as plus x as a sum, but the taking common here will not cause any problem. Let us try. X square plus 6x minus 5x minus 30 is equal to 0. Then we have x times of x plus 6 minus 5 times of x plus 6 equal to 0. So taking common, so it will be x minus 5, x plus 6 equal to 0. Therefore, x equal to 5 or x equal to minus 6 is the final solution. And if we choose different way like this, okay, then also nothing is going to change. It is going to remain the same, equal to 0. So it will be x equal to minus 6 and 5. Okay. So because x is a natural number, we will discard this possibility x equal to minus 6. So the final answer is option number C, that is 5. Let us move to problem number 9. So in problem number 9, we are asked to which of the following numbers is not a prime number. So let us first recall what is a prime number. So what we have seen in the last lecture. So prime number is a number which has only two factors, namely 1 and itself. So we have to see whether these numbers have only two factors. That 2 should be 1 and itself. Let's see. A, 197 and 313 and 439 has no factor other than 1 and itself. So A, B, C are primes, but option number D, that is 391, it has factor 17. So 391 violates our condition for set that of the condition for prime numbers. So in that case, option number D is not a prime number, and we are asked to find which of these is not a prime number. One thing, a very important thing to note here is it is asked to find which is not a prime number. Lot of times students miss the word not and they end up choosing all those answers which satisfy, because if you ignore the not, then your answer will be A, B, C. But in actual reality, what is our answer? Option number D, because it asks which of these is not a prime number. Problem number 10. X, Y, and Z are distinct prime numbers where X is less than Y and Y is less than Z. So this relation is given to us. And if their sum is equal to 70, then what is the value of Z? If X plus Y, X, Y, Z are distinct prime number satisfying this given condition, and their sum is 70. So since sum of three prime numbers are even, so one of them must be even. So this thing we have already discussed, so there is no need to discuss it again. So let's move ahead, and it directly follows that 2 is one of these numbers. So now 5 plus z is going to be 68, and we know that y is less than z, and 31 plus 37 equal to 68, so z is going to be 37. So our final answer should be C. Next, problem number 11. We have a number that is given to us, which is a binary number. Binary numbers are mostly used in computer use these numbers. Convert 1101111 to decimals. So let's see how do we do it. So to convert the given number to decimal, so what we have to do is we have to multiply the powers of 2 to these given numbers and add them. So we have here 1. Okay. So start from left and go to right. And 1 into 2 to the power 0 plus next this one. And now increase the power 2 to the power 1. Next 1 into 2 to the power 2 plus 1 into 2 to the power 3 plus 0 into 2 to the power 4 plus 1 into 2 to the power 5 plus 1 into 2 to the power 6. So after we write this, what you have to do? You have to just simply calculate. Correct? Nothing extra is remaining here. You have to just solve now. So you have 1 plus 2 plus 4 plus 8 plus 0 plus 32 plus 64. So the sum is going to be 111. That is option number A. So option number A is correct. Now, moving on to problem number 12. So convert 101 to binary number. So in the problem number 11, we converted a binary number to a decimal number. Now what we have to do? We have to convert a decimal number to a binary number. So let us see how do we do it. We have to convert 101 to binary. So 101 we divided by 2. So when divided by 2, the quotient is 50 and the remainder is 1. So again, take 50 and divide it by 2. So the quotient is 25 and remainder is 0. Again, take 25. When divided by 2, quotient is 12, remainder is 1. So again, take 12. When divided by 2, quotient is 6 and remainder is 0. And now, see, again take 6 divided by 2, quotient is 3, remainder is 0. Now again taking 3 divided by 2, quotient is 1 and remainder is 1. Now again taking 1, when divided by 2, quotient is 0 and remainder is 1. And now see from bottom to top. See this list from bottom to top. Bottom to top, write it from left to right. So 101 in binary, 101 in binary is going to be 1100101. So option number D is correct. We have 99 and we have asked to convert it to binary. So same process we are going to follow. Okay. So this time we are writing it properly, because last time we wrote in sentence form, and like this we can do it quickly. So 99 we are dividing by 2, we have 49. We are dividing it again by 2, we have 24. Dividing it again by 2, we have 12. Keep writing the remainders this side. Okay. You have to just remember that whenever you are converting a decimal number to a binary number, you have to divide it by 2. You don't have a choice. You always have to divide it by 2. And the remainder should be written here like this on the right side of the number. Okay. So when 2 is divided by 12, the remainder is 0 and the quotient is 6. When 2 is divided by 6, so okay, 6 is divided by 2, the remainder is 0 and the quotient is 3. When we divide 3 by 2 again, so we have remainder 0 and the quotient is 1, and again doing it, we have remainder 1 and quotient is 0. So write it from bottom. Okay, we have here 1 1 0 0 0 1 1, and that is D is the correct option. 1 1 0 0 0 1 1. Okay. So moving ahead. So guys, this was the last problem. Okay, I hope you understood the questions well. So see you in the next lecture, and I would suggest to all of you to just try these questions by yourselves. Thank you very much.